All right, so the webinar is being recorded and will be available on YouTube by the end of the week. The webinars of the past 3 years are already published and available with a link that I will share in the chat box. If you have any questions throughout the presentation, feel free to use the chat box that you will find at the bottom of your screen. When you click on the 3 dots, you will be able to see that. All your questions will be answered at the end of the webinar. Also, at the end of the webinar, you will receive a link for a survey to complete that is about what we did, how we will do today, and what we can improve for the future webinar of next year. So please just take a few minutes to complete it by the end of the webinar. So today we will have 2 presentations. The first one is from Mr. Neil Mcleod from FILTROX AG. Will introduce the role of filtration of wine and present the potential risks for not using filtration, and also getting a description of depth filtration used for about 25 minutes. After that, Dr. Richard Carey is gonna, coming from Tamanend Wine Consulting, sorry, I mispronounced that. He will present and discuss crossflow filtration, the pros and the cons of the different types of membranes, and how to prepare and use a crossflow filter for about 25 minutes as well. After both presentations, we will discuss and answer any questions from the audience with grape and wine industry members. Mark Germany from Fireside Winery in Iowa, Mark Wedge from St. Croix Winery in Wisconsin, and Eric May from Gusmer Enterprises Inc. So let's start with the presentation of Neil Mcleod. And so while he will be sharing his screen, all right. So let me introduce you, Neil. Neil is a global application engineer, food and beverage at FILTROX Group. He is a graduate aeronautical design engineer, spending 40 years in the process industry. Initially as a project engineer in the petrochemical industry, then as a technical sales engineer for GEA centrifuges, working in all industry sectors. Currently 28 years with the FILTROX Group, starting as a technical sales engineer, moving on to market and development manager, specializing in liquid solid separation, microfiltration systems. His current position as global application engineer, food and beverage, supporting the global sales teams and the technical department with filtration technology and application expertise. So Neil, the floor is yours. If you can put in the full presentation mode, that would be perfect. Perfect.
Okay, thank you very much for that introduction, and welcome everybody to this webinar. My job today is to talk to you about basic wine filtration. And so basically we're going to start is what and why is the filtration process used in wine? And really the process is basically removing undesirable particles from the product, and is a crucial step in the production process of wine, occurring after filtration and just prior to bottling. The filtration is used to enhance the clarity, stability, and overall quality of the wine. So basically wine is an intermediate stage between must and vinegar, and filtration is an important part that clarifies and eliminates microorganisms to obtain this physically, chemically, and biologically stable product. There are factors that influence the filtration stages of wine, and without going into detail, we just list them here as the pH, alcohol content, of course, any residue sugar causes issues, level of SO2, level of the maturation period of the wine, the finings of the wine, storage temperature as well of the wine. What I want to do, because we're talking about filtration, I want to take a quick minute just to give a definition or some idea between the two terms that we hear all the time when we're using filtration. One of them is absolute filter, and the other one is a nominal filter. And an easy way to understand this is an absolute filter does exactly what it says. It'll filter to an absolute rating. And if we were talking membrane, we'd normally talk 0.45 microns or 0.65 micron, and that's exactly what is taken out. Everything that of 0.45 and bigger, or anything 0.65 or bigger. When we're talking about depth filtration, which we're going to look at in the next slide, we talk about nominal filtration. And nominal filtration, if we were to say 1 micron nominal, it takes out the bulk of 1 micron particulate, but it's not guaranteed to take out everything 1 micron and above. And that's why we use the term nominal. We can start talking about percentages and things, but we don't need to go that deep at this time. I just wanted to make that statement clear. So really, we're talking about depth filtration today when we talk about wine. Depth filtration is a very common filtration application within the wine industry. And when we talk about a depth filter, we define it against, say, surface filtration. And here we can see on the left, there's a picture of a depth filter, a crude picture of depth filter. The unfiltered wine would be entering from the top, and the larger particles would be trapped and won't enter due to the surface gaps. And then once the wine with the contaminant starts flowing through the depth, then we start trapping smaller particulate. We can start absorbing the sticking of the products to the walls of the fibers and trapping them in the smaller channels. Now, we've got a thing that says depth filtration there, but to give you an idea, the depth filter media would be about 4,000 microns thick. And what we're looking at taking out are particles around 1 micron. So you can see a particle having to travel through a depth has to travel 4,000 times its size to reach the other side of the depth filter. The depth filters are made up of a cellulose matrix, and because of the matrix, we can actually incorporate different filter aids within that matrix, and then there's a small amount of resin that holds the whole structure together. The photo on the bottom left, bottom right side, shows a cellulose matrix, and then next to it, it shows a diagram of typical filter aids, which could be diatomaceous earth or different perlites, and these can be held within the structure. So again, nominal rated filters, we're talking about depth filter sheets, so we talk about a nominal rating. The retention in microns, there's no industry standard guideline, so it's very difficult to say I want a 5 micron sheet or a 3 micron sheet. It's best to follow the guidelines of the experts that would then guide you into what filter grade would best suit your stage of filtration. On all depth filter sheet technical specifications, there's a water value. And the reason I want to mention the water value is this water value is specifically for the quality control testing when these filter medias are manufactured. So we look at a water value and it gives us an idea of how the filter is going to operate. Now, as an example, if we look at a water value, say around here we've got an AF41, the water value stated is 240 to 300 litres per metre squared per minute. Sorry about the metric terms. But this isn't much different from the filtration flow rate, but it would be litres per square metre per hour. So it's a completely different flow rate we'd use for filtration compared to what is put onto the technical specification. So please don't take these as filtration flow rates. And then the filtration grade that we'd work with is depending on the actual filtration stage we're looking at, and filters would range from having a coarse filtration through to fine filtration and even to sterile filtration at the end. So a depth filter sheet is, as we've already identified, actually a deep structure. And so we have to look at the parameters which work with a depth filter. And the things we look at is a flow rate. And we look at a flow rate per unit area. And this is quite critical for us, that we ensure that we maintain the correct flow rate. being a nominal filter, if you were to double the flow rate, you'd quite happily get the wine to pass through the filter, but you'd start carrying through the particulate that you're targeting to trap. So then we look at the filter media grades, and we'd look at coarse, fine to sterile, and we'd actually adjust the flow rates accordingly to ensure we get the right quality product. The other thing that we look at during filtration is the differential pressure across the filter, because of course to get wine to flow from one side to the other side of the filter media, we have to apply a small pressure. And as that filter media starts to blind and get clogged up with solids, the pressure is going to increase. So we'd measure the inlet and the outlet pressure. And of course, we then would be able to say we have a differential pressure of 10 psi, 15 psi across the filter, and we can monitor the condition of the filter by watching the differential pressure increase. So now we can look at how do we actually retain this depth filter media in a mechanical piece of equipment that we can use in the winery. And here we have two extremes. On the left, we have an operator looking at what we would call a 20 centimeter filter press, and that would be 8-inch square filter sheets would fit inside that press. And each filter sheet there would offer about 56 square inches of filter area. And then the other extreme is the large 120 filter press on the right. And this has filter sheets that would be 120 centimeters squared or 47 inches squared. And each filter sheet there would have about 15¼ square feet of filter area in one filter sheet. And as you can see, the size of that filter, we can fit several filter sheets in one filter. So how does the filter sheet, the filter press work? How does the filter sheet work within this filter press? And this is quite an interesting diagram we show here because it identifies the flow within the actual filter press itself, which is quite confusing that people just see an inlet and an outlet, where actually the product flows in and then it enters inlet plates, which is every other plate. Then it flows from the inlet plate through the filter sheet that is placed within the press, and then it's collected in the outlet plates and passes out of the filter press. So this view here is a view from above with the inlet coming in from the bottom side and heading out of the top. On the left there, we can see that the actual depth filters have two different sides to them. One side is a rough, bumpy side, which gives us a larger surface area to collect surface solids on. And the outlet side of the filter sheet is actually a smooth side. And this is a side which is normally branded with the grade of filter and also has a batch number on, so the filter can be have the traceability on it, so we can see if there's any questions about it, we can do a traceability on that. This is also known as a single stage filter. So the product comes in, is filtered through one set of one grade of filter sheets, and then comes out of the press. We can actually incorporate filter sheets in one filter press and actually have a two-stage filter in the one press. Now the difference here is the inlet is at one end of the filter and it comes into the filter press in the same way into inlet plates, passes through the filter sheet and collects on the outlet plates. But now it's redirected and enters a second stage of the filter press, and we have a different set of filter sheets in here, normally a finer set, so we can do a coarse filtration followed by fine, or fine filtration followed by a sterile filtration. And it operates in exactly the same way. The diversion plate diverts the flow into the second half of the press, go through the filter sheet in from an inlet plate element through the filter sheet and collects in an outlet plate or element, and then feeds out of the filter press. And you can see the little diagram there with the arrows on, showing now the inlet is down the other end of the filter press and the outlet is still at the front. Another form of putting a filter media, depth filter media, into a mechanical structure is by creating what we call a lenticular filter module. And this uses exactly the same filter media as we'd have in a flat sheet filter media in a press. But in this way, we can form them into a module and we can pack a lot more area into a smaller volume. And then also the actual housing that can take the filter modules is on a very small footprint and can be mounted in a series or in parallel. So again, you can do multiple filtration stages with multiple housings. A good example, the larger lenticular modules measure 16 inches in diameter, and they form with 16 cells, which gives us a height of about 10 inches. And in each of these module, we can get 38 square feet in one module. So if you were to look at having one module and having similar 40 by 40 filter press, you'd have to have 26 filter sheets just to have one module. And if we put 4 modules in a housing, which we can do, then you'd have a total of 104 filter sheets in a 40 by 40 press, which is a standard wine press, or 44 sheets in the larger 60 centimeter press, which is also common in wineries. So this is a good way of holding the same filter media, but in a different format, offering a low footprint. It also offers a totally enclosed system, as we can see from this next drawing, which has got 3 modules stacked up inside it. And you can see the product flows in the bottom of the housing. We have a vent on the top, so we can vent the air out as the wine fills the housing. And then the wine passes through the upper or lower filter media, which is cut into circles, and from the outside travels through the media into the inside of the filter module and back out as a filtrate. So it's an enclosed system which can be vented, so there's no drip loss, there's no losses, and at the end of the process, the module can actually be blown down with air or gas, and so we can actually push out any residue product and minimize any losses within a system like this. So when we look at wine filtration, we mentioned earlier that we have different levels. And so what we would start at, we'd normally start with what we call a pre-filtration with a pause filter. And as a guideline here, we're looking at physically stabilized with the cold periods done, and the turbidity is not normally higher than 50 NTU. If it is higher than 50 NTU, then the wine is not ready to be filtered and needs either further fining agents or centrifugation. After the first pre-filtration, we would look at a clarification or polishing filtration, and this would be standard intermediately step for most wines prior to final filtration. For stable red wines from oak barrels, the clarification might already be the final stage for this type of wine. Also called polishing filtration, we can get to a final stage. The wine is clear and ready for bottling. It must also be microbiologically and physically stable to be bottled at this stage. And then we can sterile filter the wine, and the sterile filter with depth filter media is very common and prepares the wine to be prior to bottling, and then typically the wine would be passed through a membrane cartridge, and this membrane cartridge is there really as a guard or a policeman to ensure that there no further contamination can go into your bottle. There's good reasons why cartridge filter is put on at this stage. Normally depth filters like to work in a nice smooth continuous operation with no pulses or pressure shocks, and typically when you're bottling you need to feed the wine to the filling machine, and the filling machine will demand, then stop, then demand, then stop, and this wouldn't be ideal to work a depth filter sheet to have this sort of shock put onto it. So when to use each of the grades? We saw earlier there's a range of filter media grades. There was a a view of a technical specification sheet for the grades. But here they've separated out into the three main areas. So first of all, we would look at the coarse filtration range, and you can see we're looking at a recommended flow, and we'll call it 700 units. It's liters per meter squared per hour. Then we can go to the next stage, which would be a fine filtration. Now you can see we're already looking at reducing that unit flow rate because we're now starting to take out more smaller particulate, more delicate particulate, and we want to hold them within the structure and not push them through. And then we go to a final sterile filtration range of filter media, where we're looking at germ reduction, microbiological reduction in the first stage. And in the second stage, the one there, which is called AF130, this would be typical for red and white wines, and this would match up well with a 0.65 micron membrane as a final stage. And then for white wines, we would go to the AF140, and this would typically give us a product that would be ready to go through a 0.45 membrane cartridge for bottling. You can also see that there's a differential pressure, and this is, again, we mentioned there's differential pressure across the filter media, and we wouldn't actually want to run any higher than 2.5, 1.5 or 1.2. So the differential pressure is actually being reduced as we start tightening up the filter media. We talk about the filtration cycle, and I just wanted to put this in here because it does show from the starting point. We prepare the filter, rinse the filter, then we start filtration. And then filtration runs for quite a long period until we get to the end of filtration. Then we can do a regeneration or back flushing, and then we're ready to start again. But a lot of people say there's a lot of preparation time with depth filters, and there isn't really compared to the length of time the filter will actually run. We mentioned also when we fill the filter, there's an opportunity to vent it to expel all of the air and reduce any oxygen pickup. And these are vents on the filter press as standard, and then there's a vent on top of the lenticular housing. And here's a picture of the sight glass showing clear the water during the flushing period. Also, if you don't vent properly, you can get air in the top of the filter, and this is a typical red wine filter sheet where it's obvious the filter press hadn't been vented properly and had been run without anybody knowing about the venting issue. Again, the filter, when we look at filtration, we actually look at the differential pressure. So we start up and we have a very low differential pressure, and then suddenly the differential pressure starts to climb. If we look at the flow rate, you see the flow rate is very stable, but as the pressure starts to climb, the flow rate will drop off. And then we reach our maximum differential pressure, and it's time to stop that filtration process. Here's an example of choosing the wrong filter media at the wrong time. This is a tighter filter media which has had premature blocking on the surface of the sheet because it was the wrong sheet, a too tight a sheet for the actual process in hand. And then this is a media on the right showing a larger surface area pattern, and it's a coarser structure, and therefore we got the filter sheet to actually take the particulate into its depth and not blind up on its surface. This is actually an example of a beer filter, which has the same issues with having to filter yeast as the coarse filtration stage. When we look at regeneration, we look at two things. There's regeneration of the filter media in the forward flow, and there's regeneration of the filter media by back flushing. And there is an advantage with back flushing. And if you were to back flush a filter media, you can extend filter media's life. But you must regen or back flush before the differential pressure becomes too high. Because remember, we're filtering within the structure. And if you try and back flush or forward flush and you've started to really fill the structure up, you're not going to get an effective flushing. The diagram below here shows what we've achieved with a forward flush and then with a warm forward flush. So the first is a cold forward flush, so we don't cause any issues with heat and with proteins sticking within the media, and then we can do a warm flush afterwards and get a better recovery. You wouldn't backflush a sterile filter sheet, because backflushing a sterile filter sheet would mean whatever you're backflushing with is going to be filtered on the clean side of the filter sheet. So when we come to go forward again, you'll be pushing forward any contaminants that you've caught on the outlet of the filter sheet. We mentioned membrane cartridges. These are used in the last step of filtration prior to packaging. They're ideally suited to do a stop and start, stop and go type process where the packaging machine will demand. They're not a depth filter. They do not retain high solids loadings. So we would use them as a guard or police filter. So if anything does go wrong just prior to the bottling machine, you know you have a guard sitting there. And if that blocks, if your membrane blocks, then you look upstream to see what problems are occurring. So these are very useful when it comes to final packaging and ensuring the product is safe for bottling. Also, with membrane cartridges, you can integrity test them. This means that you can actually put a test, like a pressure hold test, where you, on a wetted cartridge, you would build up the pressure slowly. I like the bubble point one, which is the next one. You build up the pressure slowly, and you will see bubbles coming through when you reach a certain pressure. And this means that the water has overcome the surface tension in the largest hole on the membrane. And if that largest hole releases at the pressure that is on the certificate, then you know that your largest hole is still 0.5, 0.45 or 0.65. And the machines that will run this bubble point or diffusion flow integrity test will actually print out a result, and you can use that printed result to go on your quality record for the wine that goes through those cartridges. So it's a very good benefit for wine production and traceability. Now, to finish off, we just have two extra depth filter media specifically for wine that I wanted to talk about. And the first of one is, it's called our Librasol MX, and this selectively reduces Brett and mold components. It targets these components and will absorb them into its structure, but it will not take out any of the beneficial aroma or flavors that you want to keep in within your wine. This product is very easy to use as it comes in a depth filter media and can be fitted to standard filter presses or into lenticular housings. And it's been proven through testing with 15 different wineries within Europe. And it's just been released in November or launched in November as a product ready for the market. So this is a very interesting product for us. And then we also have another product, Librasol TX, and this product is also a depth filter media, but now we have incorporated a component that can selectively absorb TCA and TBA without affecting, again, any other attributes that the wine may have. And this product, it's been on the market a few years now, and it's already approved by the International Organization for Wine, known as the OIV. So again, this can be used in a standard filter press or lenticular housing. Thank you very much for your time and letting me speak to you today. And that is all that I have for now. Thank you.
Well, thank you, Neil. That was excellent. That was a lot of information in a very short time. Ode, I just want to make sure you can hear me.
Yes, perfect. Thank you.
All right. Well, I'm going to remind the audience, if you have any questions, we're going to have a panel discussion and a Q&A session after the next presentation by Dr. Richard Carey. So please type your questions in the chat box, and we'll try to answer all of them at the end of the webinar. Now it is my pleasure to introduce Dr. Richard Carey. I've known about Richard for many, many years and have been in touch with him over the last 3 years since he came to Minnesota for a ASEV Eastern Section meeting. Anyway, his story goes as this. After graduating from University of California, Riverside, Richard spent 7 years teaching college-level botany and plant physiology. He then left academia, started his career in the wine industry in 1977 when he bought his first winery. Since then, he has built more than 10 wineries and consulted with hundreds more. Tarosa Vineyards, his initial winery, was sold in the early 80s. In 1985, he took a position at California State University in Fresno as a research enologist in the Department of Viticulture and Enology. At that time, he also started Vitis Research, a consulting company. Through this company, he worked with industry vendors to create new and innovative wine equipment. Richard then moved from California to Pennsylvania in 1995 and set up a consulting operation on the East Coast. Due to state regulations, it was necessary to start a small winery, L&R Wine Company, so that he could continue consulting practices as he had done when he was in California. Tamanend Winery was a DBA of L&R Wine Company Incorporated, and the combination of Vitis and L&R proved to be a powerful force that grew. In October of 2015, both companies were sold. This allowed him to return to his roots as winemaking consultant. As part of his consultancy, Tamanend Wine Consulting operates a wine laboratory for the analysis and review of wines and ciders, as well as a wine production service business that offers crossflow filtration and reverse osmosis services for the correction of wine flaws and modification. Other services are in development. An ongoing professional activity has been his writing of technical articles about winemaking for publication in wine and grape trade journals in the U.S., specifically Wine Business Monthly. These connections, all of these connections and all of this experience have allowed Richard to travel to most of the larger wine regions of the world, to visit trade shows, and to judge at international wine competitions. Quite a lot of experience. Richard, we're delighted to have you. The floor is yours.
Thank you. Hopefully we can get through this so that everybody can have an idea about the differences between the great talk that was given just before from FILTROX. We're going to be looking at a bunch of different ways of doing filtration here. So just a lot of new and different kinds of information. So here we go. Crossflow filtration in the wine industry is a driving force that is behind it. We're going to talk about the theory, the application, and the equipment. I had thought I was going to have a demonstration of how a small crossflow filter works, but time got away from me and we aren't going to have that going today. So crossflow is also known by a whole bunch of different kinds of synonyms. Crossflow filtration is the first one that is probably most common, but the other one is called tangential flow filtration. You've probably heard about ultrafiltration, microfiltration, and of course, reverse osmosis. All of those uses the same basic type of filtration architecture so that you can get dirtier wine through, coming out cleaner on the other side. A lot of it, and when you start talking about ultrafiltration, microfiltration, it's just talking about smaller and smaller different kinds of products. It is a proven technology. It's been around. As a matter of fact, my very first crossflow filtration experience was in the early 80s from a called Millipore, and he brought this little box, and in one step I got from dirty wine to clean wine, and it's hooked me for the rest of my career. It's used in the food industry, water purification, treatment of liquid fluent streams of various types, and the industries that are using it are pharmaceutical, biotechnology industries, purifying products of high value, and it does wine. It does beer too, but we're talking about wine today. Filter aids have been classified as hazardous materials, so we're not many of the stable depth filtration materials do have some hazardous materials such as diatomaceous earth, and these particles can cause breathing problems due to PM10, meaning minor small particles that get into your lung, and it's been known to cause what's called white lung disease when that happens. The environmental effects for getting rid of the standard filter pads is through the sludge that it generates. You have very little of that when it comes to crossflow filtration. And if you in Europe, they are now charging 120 to 170 euro per ton of getting rid of diatomaceous earth if you're using that kind of a filter, although the previous talk did not talk about diatomaceous earth. There are environmental filter effects to cake production, and some of them cause bad smells, and this is a problem that you can run into. Fortunately, with crossflow filtration, it's a reduced labor on a per filter per liter filtered, because you don't have to stand there and babysit the filter and watch it. Once it's set up, it usually operates almost unattended, as long as you got some safeties in there to let you know if something happens. It has a very flexible capacity by adding on membranes, and you can adjust whatever it is to achieve the kind of capacity that you need to do. It also reduces the number of filtrations that you have to do. This is basically a one-step filtration from a 1% solids down to basically filtered ready for the bottle in one step. And you also can get more wine produced from the same input. Wine quality is, like I said, a single step down to sterile level clarity, but it cannot be used as an absolute filter because there is, as the previous talk said, you cannot get an absolute filter because you can't do a bubble point or integrity test on it. If one little tiny hole happened in one of the membranes, it would then not qualify. But it's that at the several nines after the 99 that you can get to level quality on a regular basis, even though it might not be exactly absolute filtering. It also helps in subsequent wine treatments. And what we're talking about here is that you can get stability with a brighter wine and rack directly into cold stabilization, because in for doing heat stability, it will form a very compact, more efficient ease at the bottom. You can also be more efficient at your cold stability treatments when you're doing this, unless you're using something like Zenith, which would help in cold stability without having to do any cold stability testing. And your fining is also faster with more compact leaves, because you're not having the extra little bits of solids that are in there that slow the fining down. These are some of the representative units that we're going to be talking about. We'll see some of these later on. This is just a brief lead into that. This is basically the same kind of, just a different filter company name, and you break your regular filters down into anywhere from 3 to 4 filtrations, depending upon what it is that you want to do. When you're looking at conventional filtration, you start off with each of these ones here dropping down and giving you a different flux rate, because this is the kind of curve that you get when you are filtering in each one of them. But you have to also understand that with pads, you get about 1%. You start with 1% solids, but there is some wine that is trapped in each one of these filtration levels. So that is really lost wine that you don't have when you get into crossflow filtration. It's quite a bit reduced, let's put it that way. Each step of the filtration, you can lose about 1% of the wine in each of the steps of your filter. So depending upon the number that you do, you can save a good percentage of that wine in crossflow filtration. And this is the kind of a flux curve that you get when you have crossflow filtration, where you get a certain conventional one where it falls down until you get to a point. And as you saw in the previous talk, they are developing pads where you can do some regeneration, which does help in the use of the other kinds of pads. Tangential flow, however, usually starts off fairly high, but it gradually falls down to some sort of a static level. And this level can go out for quite a long period of time. And basically, you can go as long as your flow rate doesn't get to a certain point in the cartridge that you're using. And because you can, if you run it too far, you can jam up a cartridge, and that is something that you don't want to do because that can end up being fairly expensive to repair in both time and money for membranes. So we're looking at comparisons of the different kinds of filtration here. You've got static pressure. This is the dynamics of how filter media works. If you have static pressure, you just put pressure against a filter media, and it takes all the particles of different kinds. And unfortunately, the big particles block the small particles from getting through. So you run into a point where you get a blind filter, as you saw on some of the pads that are there. Under dynamic kind of filtration, you create turbulence in the flow path, where it's turbulent flow, and what happens is the big particles stay away from the filter media, or at least further away, so that the small particles can come through. With tangential flow filtration, you have less operator time. In a single step, you go from 1% solids to 0.2 microns, and so it saves in about 2 standard filtration steps. And if you want to, one of these filters can operate on a 22-hour day so you reduce your unit costs and the need to upsize your filter. Of course, you do have to build in some safety materials such as alarms that if something happens. So looking at how how crossflow filtration works, it has various stages. The microfiltration is the largest of the pore sizes, and but in conventional filtration, you have cutoff from 1 to 100 microns in depth filtration or pad filtration, but you can get down to 0.06 to 10 microns with either perpendicular flow or membrane or tangential flow systems. The microfiltration membranes are capable of separating large and suspended solids, such as the colloids, the fats, solid particles, bacteria, and yeasts. So for wine in the target area of microfiltration is 0.2 of a micron, or it's 10,000 to 20,000 Dalton, which is molar mass. And a mole, if you have forgotten your biology, is a the gram molecular weight. So if you have a molecule that is 100 molecular weight, it's 100 grams is its gram molecular weight. And so this gives you an idea of the kinds of separations that you can do with crossflow filtration and the different types of crossflow filtration used: micro, ultrafiltration, nanofiltration, and reverse osmosis. We're most familiar with reverse osmosis in the wine industry because it can be used to remove vinegar out of the wine. Nanofiltration gets into a molecular sieve level, and ultrafiltration is where you can start doing molecular sieves of different kinds of particles that if you wanted to try to remove them from something. Microfiltration is good for virtually all of the wine types of filtration. And so it's based upon the mass as measured in grams per mole. And again, the different kinds of compounds that are separated with tangential flow filtration properties. So what do these membranes look like? There are symmetric and asymmetric membrane types. So a symmetric membrane where the pore diameter is equal throughout the full cross-section of the material, and the pore size gives you a resistance to the mass transfer, and it's acting as a selective barrier so that particles that are larger than the pore size won't get through. And this is a cross-sectional area of what the membrane can look like, and it's fairly uniform across the cross-sectional area. So this is a symmetric one. Most of the crossflow filters these days are done in asymmetric level, and that's where the pore size on the surface is small relative to the cross-section. It's got a very thin skin on the top layer that determines the selective barrier, and large particles that can't enter and don't pass through the membrane and get embedded in the membrane body. And it gives a fairly high, sometimes higher rate of permeation through that thin membrane, and gives you a great deal of selectivity. This is what a crossflow membrane looks in its tubular form, where you've got this thin membrane And you can see that it is asymmetric because these are the pores where once it gets past this barrier, it flies out the other side. This is another cross-sectional area at a molecular weight of 300 molecular weight. So it shows you how a particle can get through once it passes. So it gives you a very clean selectivity of the membrane and its pore sieving. You can design in hydrophilicity or hydrophobicity, and therefore to help in the interactions with the materials that are passing through. And you can even build in a membrane charge. We don't have time to go into some of those details here. And this is another micrograph of that kind of a membrane. So these skins are 1/10 to 2/10 microns, and you get a 200 to 500 micron body that is in here to give you structural strength. Then there's inorganic membranes, and with inorganic membranes, they're made with aluminum oxides, and you can get different size aluminum oxides, and then that's the coarse area, so you have that same asymmetry, and you get then a different kind of aluminum oxide to give you a little bit more structural strength, and then the actual material that gives you the surface is silica, and that's on the surface of it. And many times these are called ceramic membranes because you have to take the material and heat it in an oven to get it sintered together to hold its structural amount. So we talked about the deadhead filtration here. I'll go on to, and the formula for that is the transmembrane pressure is the pressure of the feed versus the pressure of the out, and that gives you a transmembrane pressure. In tangential flow membranes, though, it's a little bit more complicated because you want to have your turbulent flow here against your membrane surface. And by maintaining your turbulent flow, you have a different kind of formula, which is the pressure of your feed versus the pressure of the concentrate, and divide that by 2 versus what's called the permeate, which is the pressure of the filtered material through the membrane. So that's your filter stream pressure, concentrate pressure versus the permeate stream pressure in that formula. So membrane dynamics, if you have water going down a membrane, you can look at transmembrane pressure, the pressure of the fluid that you're trying to pump. And when water is your only material in there, the flux rate of the water is directly related to its pressure, again, transmembrane pressure. But as you start to get materials in there, you reach a point where no matter how much pressure you have, you aren't getting a direct line in your pressure flow. You start to get the critical flux falling off at some point. And as you get more and more other kinds of particles, this critical flow flux rate, it gets to be at a lower and lower flux rate. And then down the stream, you have what is called your mass transfer flow region. And the limiting flux is how much you can get through on the membrane. And this is your sort of your paradox. Where do you find the sweet spot so that you can run your system so that you have a lower concentration feed, a higher temperature, higher flow rate, and you get this flux paradox of trying to find out what that critical point is. Keeping all of these in mind, how this system works. And then there's membrane interactions. And the membrane interactions is you obviously have pore blocking, which is the particle gets embedded in the pore. You have adsorption, so that particles can get adsorbed onto it and create resistance. And then you have the actual membrane itself is creating its level of separation. And then you have this thing called the gel layer. And we're going to come back to the gel layer here because that's something we have to talk about in a little bit more. But then you have other parts of it, which is what we call the concentration polarization. As you get to more and more levels of concentration, you have particles interacting with one another in your wine as it goes through the membrane in getting to its final end. So this is what I was talking about. You have your feed flow down a membrane, and as you can see, the particles are very low density here, and they get higher and higher density here. So, and this is your permeate, which is the clean wine that is coming through. if you imagine a membrane is like having a cheese grater that has a lot of holes on it, and you have a handful of marbles, and you're going to throw them in at the beginning here, and these marbles are all of different sizes. And if you throw them fast enough, the marbles are going to start going through here fast, and they're going to start bumping down, and you're going to get to a point where there's a gel layer here, and the marbles are just sort of bouncing along. Pretty soon, a marble's going to stop. And if a pore happens to be there that's the right size, the marble will fall through, and that's your particles going through the membrane. And so it's real easy for the smaller ones to find a place to come through, and it gets to be a lot harder when you get down at this end of the way. And this is where you start getting at the end of if you're starting your wine at this point here, you're getting down to the end. These are the larger particles that are slowing your flow rates down later on in your concentration. So there's different configurations of crossflow filters, and we've got polymeric membranes, we've got spiral membranes, and when we finish with here off of the screen, I'll show you a diagram of a little bit of something so that you can get an idea about this. There's tubular membranes or hollow fibers, there's plate and frame membranes, there's inorganic membranes, and there's other specialized ones that we have. So let's go through this. This is an example of a ceramic membrane. They take a ceramic tube and embed it in a large tube here, and you'll see some close-ups of the ceramic membrane types. There are hollow fiber type membranes here. These are little tiny tubes, and I'll show you this a little bit closer up in another one. And you've also got stainless steel membranes, and here you have sintered stainless steel that does essentially the same thing as you're making the ceramic membranes, where you have different grades of stainless steel that they then fuse together to give you a membrane-like surface where it's very fine on the inside and it gets to be more and more coarse on the outside. So, and then you have spiral wound membranes, and this is the one that I'm going to or later on. But this is a spiral wound membrane where the membrane here has a cover on the outside of it, and it has membrane material here. They are fused together, and the membrane is wound very much like a jelly roll, so that the jelly roll is outside here. Your dirty wine goes in these spaces in between, and there's a membrane sheet that's in there, and the material goes through from the dirty side to the clean side of the membranes, and it spirals down into the center, and this is in the center, and this is where your permeate comes out. And that's a spiral wound membrane. So here's a hollow fiber membrane, and you get many of these hollow fibers. And this one here, your dirty wine goes in the center here, and it permeates to the outside, and it's collected and comes discharged into your clean side of the tank. And this is the dirty wine separation going back in. So this is a ceramic membrane, and you have ceramic membranes that have the pores here for where the dirty side is going down these holes here, and the clean wine goes to the outside. And you have different sizes of these because this kind of ceramic membrane can be used for leaves, different kinds of products. There's all kinds, because this goes into a lot of different industries, so they have many different kinds of ceramic design membrane modules. So to get into how this thing works, you're going to see a source tank, which is the source of the wine, feed tank, the destination tank. You have permeate, which is the clean material that comes through. The retentate is the dirty side. We talked about back flushing, which reverses the flow from the retentate, the permeate side into the retentate to take care of that gel layer. And then we have batch operations, continuous operations, and then there's going to be feed pumps and recirculation pumps. So we'll look at all of these coming up here. The first operation is called a batch operation. And a batch operation, and this is a large winery's batch operation, because a large winery could have a source tank that is a quarter of a mile away from where you're going to do your filter operation. So you use a feed tank to bring it down into a source tank, the feed pump into your feed tank. And then the feed tank begins its circulation because it takes the discharge from the tank, through the membrane, and the dirty wine goes back into the feed tank. So this is a loop that is going on around and around. And have a backflush system, and the backflush system will reverse the permeate flow so that it can go in when you switch the backflush. This is a valve that the backflush takes some of the clean wine and forces it backwards through the membrane, and it shuts off the flow at this point so that it cleans the membrane up. And so this is the dirty flow that goes around here with this flow right. And you have to have a way to have the backflush put the charge back into the dirty tank. So this valve keeps switching back and forth. And this is a simple, relatively simple batch flow for a larger size winery. For a staged batch, this is the same arrange kind of thing here, but what you don't have is necessarily have to have is a backflush system. It can go round and round, and you can get what you end up having in this situation is that you run an initial source tank at a distance so that it will go through the system one time into a concentration tank, and you then use this as that you can get rid of the initial source tank and then have it all in a more localized place so that it goes into your destination tank here. Again, these are for somewhat larger size wineries. They do have continuous stage wineries where you have your feed tank, a bunch of membranes, and your permeate is going constantly into another tank. And once the feed tank is all into here, it gives you your wine, and you can send the concentrate back to a different location if you're not going to use. You're only going to filter part of it. But then you can have a staged permeate tank where you have multiple stages of these things so that you can continue this feed going and getting more bang for your buck on getting more units that just line up. And there's larger size systems that will be multiple millions of dollars that larger wineries can use. You can also, with crossflow filtration, adjust pH. And this is a way that you can use and this is especially the case for smaller wineries, because if you have a wine that has a high pH, you can take your high pH wine, and by making a couple of modifications to your membrane, you can have your high pH wine go round this way and go back into your tank. And then on the clean side where the permeate, it goes this way through a permeate, through a resin tank. It goes back into your primary tank, and it is pH reduced because you use a cation exchange resin in this tank, and this is the only legal way that you can adjust pH in your wine, because larger wineries eliminate what they do is that they just pump their wine directly into the resin directly. But smaller wineries, there is an effect of your wine on the actual resin material, not the process of the resin, but the resin. And so by putting a membrane that will allow only the small molecular weight part of your wine go through here, you can introduce your hydrogen ions back into your source tank and lower your pH. So again, same list as we had before. We have Delatopola. This is an example of one of their kinds of units. This has a ceramic membrane system. The Delatopola is Omnia, and they has a large number of ceramic membranes in here with one single pump that turns things around. This is your backflush unit, and this is all automated so that you can operate the system in a continuous fashion. VLS is semi-automatic, and it does it based upon a program that you can monitor while you're doing it, and less stainless steel membrane system, and they have a pump for each one of their housings where they're running wine round and round and round on this. And this is one of the larger kinds of systems. Padovan has a hollow fiber, and all of these different types. I'm giving you just examples of what filters look like that other companies have, because they all provide hollow fiber. They all provide ceramic in large degree, and ATP is the one that does Padovan, and this is the ATP's Padovan's ceramic kind of membrane system. And then Creveller has their system, and they are getting into bring Creveller in here now because they are bringing in a smaller scale system for smaller wineries. One of the few smaller winery systems that is out there is Romfill by Euro Machines USA. This is a hollow fiber unit, and this one here is for one of the smallest of the systems, other than the one that I have developed, which is going to be entering in the market now. I'm just starting to get it into the market, and this is the smallest crossflow filter that is on the market that at least that I know of, that I just have created. This is a front view of the system, and this is a side view of the system. And basically, the system, the pump is on this side where you put your inlet. The discharge of your dirty wine goes in the lower level here and comes back into the filter, goes back around, comes back down the other membrane, comes back through this backside membrane and into here, and goes out into your into concentration tank.
Richard?
The permeate comes into here, and if you need to do a pH adjustment, you can do it on this tank, use a resin tank, and I can talk about that more later.
Richard,
Thank you.
Oh, are you just finished up?
Yeah.
Oh, I'm sorry. I was going to say you've only got a couple minutes left.
I'm finished.
So
Questions?
Yeah. Thank you for that talk. I'm sorry to interrupt you at the very end like that. It wasn't my intention. It sounded like you had more to say.
Nope.
Anyway, as a reminder, to all participants, please type any questions you have in the chat box, and we'll answer them. We're now going to be joined by Mark Germany from Fireside Winery in Iowa, Mark Wedge from Dancing Dragonfly Winery in Taylors Falls, Wisconsin, and Eric May from Gusmer Enterprises is going to join us as well. We have these are a wonderful panel of filtration experts and practical winemakers with lots of filtration experience. Ode, do we have any questions in the chat box?
So first, I want to thank very much Neil and Richard for your great presentation. It was a lot of information, but perfect. So we have a question about smoke taint. With the increased potential of smoke taint from grapes in a few states with wildfires, is there something like Librasorb being developed for the removal of smoke taint?
I think
can tell you
that's
that
for
there is,
Neil.
yes, and that there are membrane systems that will remove the smoke tank. It's a one that has just gone through review, where it's a membrane that will actually.
We didn't hear the end of the sentence, Richard.
There's a membrane that can remove the smoke taint out of the wine. We're using a crossflow membrane system. I don't know exactly which company it's going. It's just been released, and they just have their patent on it coming into play. But there is a membrane that does it, and there are some other ways of doing it too, where you can run some resin columns to remove through crossflow filtration.
And Neil?
Neil, I think maybe you could back this up. And I've actually worked with some smoke taint fruit before, back when I was in Texas, and found some really, really good results using carbon filtration through filter media from FILTROX before. Do you have any comments on that?
Yeah, I mean, I would add to that we have a couple of products that I spoke about, which are very selective in what they will remove from the wine. And yes, you can use things like activated carbon and other things. But what we would do in the future is, if we were to look specifically at smoke taint, we would look specifically at removing smoke taint only, and not affect the other attributes of a wine. And that's where you can always remove something, but in removing it, you've got to target it specifically. Otherwise, you start removing things that you really want to keep in your wine. Smoke taint, last couple of years, it's been predominant around the world because of the fires we've been having. And so it has been something that has been brought to our attention. But for us, we target things, and it's unfortunately not a short process to find the right solutions.
And with smoke taint, unfortunately, a lot of it is a bound phenol glycoside, right? So this is a bound up chemical that can be removed with selective membranes, but not similar to the filters that are selective to those specific compounds. Enzymes in fermentation and enzymes even in your mouth, right? Like you can have a smoke taint that doesn't appear until you're actually physically drinking that wine. So it can be difficult to remove in that situation.
Thanks very much. We have another question, which is a question that Mark answered. Would there be any reason to keep the discarded wine from the crossflow to top barrels? And so that's a good answer that Mark, Germany, you provided, saying discarded wine from crossflow is mostly particulate matter, so dirty wine, not advised to use for topping.
And I think it's really a visual thing. I think it's one of those things whenever you do a crossflow filtration, seeing what is left over would really kind of help give you that visual aid of understanding why you wouldn't want to use that wine. But again, just to reiterate, it's all the leftover particulate matter, dirt, lees, all that kind of stuff that you're trying to take out of that wine. So I think it would be ill-advised to add that back to a wine that is currently maturing and in the fining process.
I will just jump in to say, because I don't want to assume what she means by discarded wine from crossflow, the retentate, I believe. But we can, in the body of a crossflow filter itself, I believe, correct me if I'm wrong, Richard, that you can use nitrogen to, whatever you want to call it, blow down or try to get every drop of wine out of the membranes, out of the body of the filter. Isn't that correct?
Well, yes, you can, but it isn't built when you're pushing it out that way. You're not getting anything through the membrane.
Okay.
You can. One of the items about crossflow filtration is that you really would like to have your crossflow filter what we call the hold-up volume, the minimum amount of liquid that it takes to have the system run. You want it to be as close to 1% of your volume that you are going to want to filter in order for you to be efficient in getting everything out of it. So that's one of the reasons why my system is one of the smallest hold-up volumes around. And so you can use it for smaller. As a matter of fact, I have an adaptation on it that you can get that where you can use it on filtering down to about a hectoliter. So that's what you want to try to do for crossflow filtration.
Let me jump in real quick, Richard, and get to the bottom line for some of our participants on your new system, which is a single membrane system. Again, let's just talk about the base model right now.
Right.
What is that going to hit the retail market? What will be the cost for that?
The base unit is in the neighborhood of about $13,000.
Substantially less than even some of the smallest systems that the other companies make.
Like that Romfill one is in the neighborhood of about $45,000 or $50,000.
Yeah. Yep, and they go up from there, depending on the company, the type of material of the membrane, and how many membranes, et cetera, et cetera.
It's going to be available at Crevellers. if people want to know, or they can call me, but it's going to be available. Creveller is going to be my distribution.
Excellent. Excellent. Ode, any other questions?
So before answering another question, I would be happy to hear about what system you have in your wineries from two of you. So Mark and Mark, can you share with us what type of filtration do you use? Do you use crossflow? What type of membrane? All of those specificities that were presented.
So here at Fireside, we're producing about 18,000 cases of wine a year. So a crossflow is economically a good decision for us. It is a very expensive system. It does require some very meticulous upkeep, but I can definitely speak to the ease of use once you understand how the system works. So when I came here from Texas, I did zero crossflow filtration in Texas. Got here, found out we had a crossflow, very short learning curve with it. And I'm gonna tell you, whenever you say you can set it and forget it and you can literally walk away, I'll hook it up to 1,000 gallons of wine before I leave from work for the night. And as long as everything went okay overnight, it'll be done by the time I get here in the morning, which is pretty fantastic. It's a very self-contained system. However, there is still need for use for other filtration types here in our winery. So, I encourage you, if you buy a crossflow filter system, don't sell or get rid of your plate and frame filter. You're going to need it one day. I can promise you that. There's going to be that specific application where you need to get a wine clean enough to even go into your crossflow. The other thing to consider is working with fruit wines, as we do. So for Ackerman Winery, which we produce wine for as well, we make fruit from just about anything you can imagine. And there are some fruits that just don't like to work with that crossflow filter very well. For example, mango. Mango has a lot of bizarre enzyme characteristics to it. It likes to throw a lot of pectic haze. You really, really have to watch that wine before it goes in there. Same thing with mead. Mead is a very, very difficult wine to crossflow. So that's where having our plate and frame filter still in house is extremely important to us. And then, of course, after our crossflow filtration, we're still always going through cartridge filters on the way to the bottling line because those are an absolute sterile filtration. And here in the Midwest, with as much sweet wine as we're producing, that absolute sterile filtration is absolutely important. So, that's just kind of a quick rundown of what we're doing here at Fireside.
Thanks, Mark. Mark Wedge?
We are a little more traditional, I guess. We are sub 10,000 gallons. I use the same protocols I've used for probably the last dozen years. Plate and frame, the last half dozen years, coincidentally using FILTROX filters. I don't know if it's overkill or just right, but I haven't had any problems. Our standard protocol would be a 41, which is a 5 to 9 micron, drop down to a 71 and a 101 in series with a diverter. And then if we're doing any RS adjustments or anything like that, make the addition at that time. And then it'll go through a 130 within 24 to 48 hours, preferably 24 hours, but up to 48 hours before we're ready to go through a membrane and to the bottling line. If you wait longer than that, you can have problems. Then we'll use 2 cartridge housings in series. We'll do another pre-membrane cartridge and then a 0.45 sterile membrane. There's very few wines that we do not sterile filter. Tawny ports and perhaps a dry red if we can verify that it's all ML positive. Nothing's been added to it to round it out that didn't have ML. But a lot of our wines do have at least a small percentage of RS, so those would all be subject to sterile filtration.
I tell my friends in California all the time that you'd go out of business here in the Midwest if you didn't make a lot of sweet wine. I had to learn it for myself when I came out here, and it's true. And I've even myself come to appreciate a little bit of sweetness from here and now, here and there. Again, we tend to have these low pH, high acid wines out here, and it's amazing how even just a 0.5% or 1% of residual sugar will help balance them out, kind of take the edge off, make that fruit pop up a little bit. Ode, have you been watching the chat box?
Yeah, so we do have a question about ceramic versus hollow fiber cross flows. So can anyone speak on the user friendliness and effectiveness between those two?
But
I can't
the
specifically
biggest difference
speak to one
between the
versus
two
the
of
other,
them is
but
cost.
I will say we use a hollow fiber crossflow here. We love it. It's great. There are some negative aspects to it, from the aspect of eventually over time you are going to have leakage in those hollow fibers. So you really do have to have some understanding of how the system works. Whenever you do have a leaking fiber, you will have to actually disassemble that part of the machine, do a very specific protocol to plug that hollow fiber so that it bypasses that fiber. And I will tell you, as you know, depending on what level of winemaker, if you are that type of winemaker that has to call somebody to get something fixed, maybe crossflow's not for you. Otherwise, you will be replacing that part of the cartridge, the actual hollow fiber cartridge, which is extremely expensive. So having that understanding of how maintaining that part of the system works is really, really important. There are hundreds of hollow fibers within that cartridge. So you can, effectively plug them until you get to a certain point. And then once you hit that certain point, you are going to have to replace those cartridges. You should be able to get a very, very extended time, a very extended lifespan out of that cartridge, assuming that you're using the system correctly. As for the overall user friendliness, again, once you understand how the system works, it's extremely easy to use. My only kind of drawbacks to it are that whenever you are returning wine back to the tank that you're filtering from, which is the way that we do it here, that wine is turbulent. It is exposed to oxygen, so you have to make sure that you're keeping nitrogen in the headspace of the tank constantly, and the headspace of the tank that you are recirculating back into. But the other thing you really got to think about is it's encouraged to test your dissolved oxygen pre-filtration, post-filtration, to make sure that when you're using the filter that you're properly purging all of the oxygen out of that system, so that it is a true closed loop system. But I will tell you from experience, it doesn't matter if I have a wine that is 30 ppm of free SO2 or 15 ppm of free SO2. After crossflow, it is always 8 ppm of SO2. So it's something that you really, really have to stay on top of, pay attention to. You have to truly know that no matter what, you are going to have to make that SO2 adjustment afterwards. So don't just assume that you've mixed up your sweet wine, you've got what you think is the proper level of SO2, and that you're in a closed loop system, that you're going to have a proper level of SO2 after filtration, because you will not.
And Richard,
Very much.
yeah, I was
Difference
going to
between
say,
crossflow filtration, hollow fiber and ceramic is extensive because the ceramic ones are quite a bit more expensive, but they do last a lot longer period of time, and they are not as prone to fouling with solids, or if you do, you can get the ceramic ones clean a little bit easier. But Mark is right about the potential for problems of the hollow fiber having get some breaks in them. But in my experience with lots of different wineries, the lifespan of hollow fiber is in the neighborhood of 5-10 years. So you don't really have to worry about it too much. You can get tens of thousands of gallons through it, and so on a cost per liter basis, it's not that big a deal. But if you've got
we're on about 7 or 8 years here.
Yeah,
to kind of give you an idea.
It's a very, very efficient way. If you've got the money, ceramic can be good, but that's usually for the larger size wineries. For anything that's under about 20,000 cases, I don't think they're going to be wanting to have ceramic. Not because it wouldn't work, but it's just a cost effective.
Yeah, it's probably even larger than 20,000 cases. Honestly, the difference between user friendliness as well as the automation standardization of it, the technology itself, as was discussed, can be scaled down to a very small scale that you have to watch. But part of the conversation that we were discussing, right, was automation. Mark saying he was able to press a button, step away. A lot of that is dependent on how much automation is there, and a big portion of ease of use doesn't necessarily come down to ceramic versus hollow, but instead how programmable it is, how easy it is to set up with your alarms and right size there. I will say the hollow fiber crossflows, when there is something that goes wrong or you put something in there that you're not supposed to, and it does get damaged, it's a lot less costly to fix those. If there's damage to the ceramic membranes, you're paying for a new ceramic membrane. You're not going to be able to necessarily go in and just plug a couple of hollow fibers. So definitely pros and cons to each.
We'll say my particular kind of membrane, which is a spiral wound membrane, it is less costly and it has no automation. It is for the simplest people that need to have filtration, that want to babysit it and can babysit it. When I say that, you're just going to be there. You don't want to walk away from it, but it will work without any problems. You just have to know that this is no automation. You plug it in, turn it on, and it works.
Yeah, and Gusmer's is the exact opposite. It'll be fully automated, but you do owe me your firstborn child if you buy it. So just know that as well.
Good.
I just want to make sure we get all the questions in. We've only got a few more minutes. There's a question, Neil, about the Librasorb product. Do you know if it was tested on any non-vinifera wines? Here in the Midwest, we do a lot of hybrid grape wine. Can you speak to that?
No, it hasn't been tested on any of those types of wine, but it does target specifically the EP and EG phenols that are created by the Brett. So we'd assume it would be similar.
And I can just add that I happen to know that there's a local FILTROX representative here in Minneapolis or Minnesota, the upper Midwest, who can he can come to a winery and do a benchtop test with a small amount of wine, even just a half a liter of wine and a small disc of that media, and can do a very quick bench test right there in front of the winemaker. The winemaker can sit there and taste and smell before and after. So there's that as well. And any audience participant who wants more information on possibly having some of these tests done can reach me, and I can put you onto that sales rep from FILTROX. Any other questions? I'm just looking here.
I do. So while I've got 3 filtration experts on this panel, I'd like to really discuss, I think all winemakers kind of have this in the back of the head. Whenever you're filtering a product, are you removing tannins? Are you removing anthocyanins? Of course, there's always negatives, that you're removing, but there's always going to be some positives that you're removing with it. I've done a lot of research on trying to figure out what the actual particulate size of different tannins are. There's not a lot of research available that I can find around that. So figure while I have some experts on the panel, I'd like to ask that question.
What I have found out is that with 0.2 of a micron, and if you have more than 90% concentration, 95% concentration, you only notice during the first month or two that a red wine might seem a little bit lacking, but almost 99% of the time after 6 months, it's right there.
That's my experience as well.
Is it true for non-vinifera?
It's done. I've done Chamberson with it. I've done everything with it. So I mean, I've had crossflow filtration in my winery and here on the East Coast, and done all kinds of different things with it. So no difference, vinifera or hybrids.
I once put 18,000 gallons of Santa Barbara County Pinot Noir through a two-membrane filter. It took 28 hours, and it was going pretty slow at the end, but it finished in one pass. That was 20 years ago. It was just amazing. There's a quick question here. Is crossflow filtration too tight for red wines from barrels?
No.
No, I don't think so either. Yeah.
No.
It's amazing how much dirt you can put through a crossflow.
0.2 micron.
And I will second. I will say I have taken a wine that literally finished fermentation a week before I filtered it, and it runs right through. It might run through at about 4 gallons per minute, but it'll run through. It's just the really difficult wines, difficult fruit wines, but as long as you're pretty much, you know, if you don't have residual bentonite, like if you're not filtering straight from a tank that you haven't racked or anything like that, you don't have any PVPP or any other fining agents like that, crossflow's a beast. I mean, it'll pretty much filter anything.
I believe one of the large ingredient manufacturers has a crossflow friendly form of bentonite. If anybody has any questions about that, contact me directly, and I can lead you into that direction. We've only got a couple minutes. In 30 or 40 seconds, Richard, how do you clean a crossflow filter? Do you use caustic or just sulfur citric or?
The membranes have a pH level that they tolerate. You have to go by the membrane company. But for the membranes that I'm particularly using, that's pretty average, is you get a pH of about 11 while you're recirculating for a certain number of minutes. Then you chase it with a little bit of water. Then you put in some citric, and then at the end you're clean. You do have to make sure that you store it with at a pH of 11, so that you aren't going to get any growth in there if you're going to be longer than about 3 weeks from the time that you're using it. If you're within that window, you can just let citric be in there for that.
Excellent. Well, Ode, do you have any closing comments? We're here at 90 minutes.
Yeah, I just have one comment. Please take time just to complete the survey that is available on if you scan the QR code or just the link that you will receive by email. But most important thing, thank you very much to all our presenters and panelists. Thanks for all that great information. It was great. So if you have any question we didn't answer, please send an email to any of us and somebody is going to reply to you. And on that note, stay tuned for the next season. So next year, we will come up with new topics. But if you have any suggestions, feel free to add them into the questionnaire or the survey, or send us an email with all your topics you want us to cover next year. So on that note, happy holidays. Thanks very much, everyone. And yeah, have a good season. Bye.
Happy holidays, everyone.
Thanks, everybody.
Neil,
Thank you very much.
Neil, thank you for staying up so late for us.
Yeah,
Just know Neil's in Europe What, 11 o'clock at night now, eh?
It's time for a cold beer, I think, Drew.